Welcome back to Edumon tutorial series. I am Guru Renuka, instructor for the subject Elements of Electrical Engineering. So in this lecture, we are going to discuss about the speed of DC motor and the losses and efficiency of a DC motor. Now let's get started. So speed of DC motor. For a DC motor, we already know that the back EMF can be given with these two equations, that is EB equals to V minus IARA and EB equals to P5ZN by 60A. So when we equate these two, we get N value as V minus IARA by 5 into 60A by PZ. Okay, and this 60A by PZ, this value is a constant, right? So let's consider it to be some K. Okay, so N equals to K into V minus IARA by 5, and this V minus IARA is EB, right? So when we put it here, when we substitute it here, we get N equals to K into EB by 5, and since K is a constant, we can say that N is directly proportional to EB by 5. That is, the speed of a DC motor is directly proportional to the back EMF and it is indirectly proportional to the flux. Okay, this relation is really important for you to solve sums and problems. Okay, then coming to speed relations in a DC motors, consider a DC motor. Initially, it has the values for speed, flux and back EMF, and this armature current is N1, Phi1, EB1 and I1. So then the corresponding final values are N2, Phi2, EB2 and Phi IA2. So from this relation, it is evident that N1 is directly proportional to EB1 by Phi1 and N2 is directly proportional to EB2 by Phi2. Okay. And we also know that in a shunt motor, the flux is practically constant, right? So when we divide these two, that is N1 by N2 equals to EB1 by EB2, since Phi1 equals to Phi2. Whereas in series motor, this flux is directly proportional to armature current IA. So N1 by N2 equals to EB1 by EB2 into IA2 by IA1. So these two relations are also important. So kindly remember that. So now the speed regulation. Speed regulation of a motor is a change in speed from full load to no load, and it is expressed as a percentage of the speed at full load. So the percentage speed regulation equals to no load speed minus full load speed by full load speed into 100. We denote this no load speed with N0 and the full load speed with N. So that is N0 minus N by 100, N0 minus N by N into 100. Okay, this is the percentage regulation, percentage speed regulation. Then coming to the losses in a DC motor, it is same as the DC generator. Since we have finished the DC generator topic, it is really simple for us to learn the DC motors because it's a comparative study, right? Okay, so the losses in a DC motor are the copper losses, the mechanical losses and the iron losses, and these three losses cause increase in temperature and reduction in efficiency of the DC motor. And then when we talk about efficiency of a DC motor, it is given by output by input into 100, right? And what is this input? Input is output plus losses. So efficiency eta equals to output by output plus losses into 100. And this output is maximum when the variable losses are equals to constant losses. And coming to this topic, we have already finished it in our DC generators. Okay, so check it there. And coming to the power stages in a DC motor, there are three stages. It is again same as a DC generator, but again we'll discuss in brief. First state, it is the input. Okay, second, it is the mechanical power developed in armature, and the third, it is the output power of motor. So initially, when we see from input, that is V into IL watts, on removing the copper losses, we get the mechanical power developed in armature, that is EB into IA watts, that is the B stage, from which after the friction and iron losses, we get the output power of motor. So the copper losses, it is given as A minus B, right? And the friction and iron losses, it is given as B minus C. Okay, and the overall efficiency is C by A, that is eta C, that is output power of motor by the input power. So it is stage C by stage A. Coming to electrical efficiency, it is B by A. And then coming to mechanical efficiency, it is C by B. Okay, it is same as a DC generator. Okay. So in this lecture we have studied, we have finished the speed of DC motor and the losses and efficiency of DC motor. Thank you.